Hello, good morning, good evening, good afternoon, wherever you are in the world. I always open up like that. Hopefully, everybody still enjoys it. My name is Michael Levan, and I am here with Elli from PerfectScale. And today we're going to be diving into all things performance optimization, cost optimization, resource optimization, everything and anything Kubernetes specific. And I feel like in this space, and I'm sure you feel this way too, Ellie, where there's so many words and so much verbiage around like what this space actually is. Some people call it cost optimization, some people call it FinOps, some people call it resource optimization, some people call it performance optimization. Where does it kind of sit for you?
Hello, Michael. Great question. So, from our point of view, the problem is we call it a day two, like a crucial part of day two operations. Day zero is when you plan everything. Day one is when you build everything. Day two is when your system is actually live and serving your customers. And this is where the journey of continuous maintenance of your environment starts. And continuous optimization is basically making sure over time, as your system grows, as your system changes, making sure that your system remains efficient on one hand, but on the other side provides the desired level of resiliency and serving your customers with the expected SLAs.
Makes sense. Makes sense. So in this space, again, whatever we want to call it, we'll go ahead and call it performance optimization. In this space, there are, a lot of products, a lot of tools, a lot of vendors, ranging from startups to, AWS is doing cost optimization, resource optimization, Microsoft, cluster autoscaler, right? Just like by itself, Carpenter, all these things. Uh, in your opinion, right, what is the value proposition, from a PerfectScale perspective? And the reason why I ask that is because, I'm sure there are a lot of engineers on here saying, oh, another tool, another thing to learn, et cetera, right? So we kind of want to give them the why behind the value proposition. So I'll go ahead and let you handle that.
Yeah, absolutely. So there is a lot of different tools calling for different value proposition, as you correctly stated. Most of them focusing on the cost reduction because running Kubernetes is kind of expensive. But the actual problem, or like if you look from the financial standpoint, the problem is pretty easy. Yeah, reduce the resources that you don't use and stop wasting money. That's pretty simple. But when it's come to the engineering, when you come to the engineering with such a task, the first and the most important thing is, okay, but how do I do it? Where are the resources that I can safely, and the focus is on safely, reduce without harming anything, without breaking anything, and making sure that I'm still running, I'm still working. Focusing on this perspective, and by the way, that's one part of the value proposition. So yeah, you can save 80 or 100% of Kubernetes if you turn your Kubernetes off, but that's not what you're trying to do here.
Right.
That's one part. And the second part is being proactive. Most of the companies relies on the monitoring. And monitoring is very reactive approach. Once the problem is there and you was smart enough to configure proper alert, then you will know that something went wrong, and then you jump on and fix. A lot of adrenaline. This is why we love being DevOpses, but eventually we can do better. We can do proactive, and even more, we can do prescriptive. And what PerfectScale brings is this continuous, and it's not only the data. Yeah, we have all Prometheus, Datadog, whatever monitoring solution we have. We have a lot of different FinOps solutions. They have all the data. There is ocean of data where you don't. But having this data does not mean that you have the answer. That you have clear prescription of what you need to do in order to make your environment healthy and efficient. And this is what we set for us as a goal. This is what we do.
Yeah. So two really, really good points. The second thing that you talked about, yeah, having the data, it doesn't mean much, right? We've had logs for 40 plus years, and the majority of the time we don't do much with them. So it's very true. And then, the first part that you mentioned, you hit the nail on the head. And this is the same thing that I talk about all the time when it comes to resource optimization, when it comes to, overall performance optimization, because I've had clients in the past from a consulting perspective that say, yeah, we want to do cost optimization. And I'm like, awesome. And they're like, so what we're going to do is, when workloads are super low, when resources aren't being used, we're going to drop our Kubernetes, worker nodes down to one worker node. And I'm like, no, that's not cost optimization. That is throwing everything down in a bucket that you've worked on so far. That is not a great thing or a good thing to do. Saving money doesn't help if your application is performing terribly, right? If your overall environment is not following best practices. So you really hit the nail on the head there talking about cost optimization, because a lot of people think, oh, we're just going to save money. But in reality, cost optimization isn't about just saving money. Cost optimization is also about maybe paying more, because that means your cluster, your environment, your application stack wasn't performing the way that it was supposed to be performing. So once you implement resource optimization, guess what? You may be paying more. And I think that, a lot of people don't think about it like that from a performance and a resource perspective, because they think, oh, resource optimization equals saving money. No, sometimes that's not the case. Performance optimization means making your cluster work as good as it possibly can, which sometimes means spending more money. So, of
Yes, that's absolutely true. And if you will allow me, I will share for a second
course,
one slide.
please.
And this slide is, sorry.
No problem. Take your time. Yeah, the you should see a present button at the bottom. Sometimes it's kind of hiding.
Yeah. All right. So I guess it's visible now. So this is what we see across all the clusters, and we monitor hundreds of them, many hundreds. And also not us only, but Datadog did the similar research for 1.5 billion containers that they analyzed over a long period of time. 70% of the resources are wasted. This is a memory and the CPU, which eventually translates to the bill that you are paying, and not only this, is also translates to the carbon footprint, because eventually, when you're running the computer, you have also CO2 pollutions, and at the end of the day, we're all sharing the same planet. So optimizing this will also help the planet. But at the same exact time, there is around 20% of the workloads which are continuously struggling with problems like out of memory, evictions, CPU throttling, restarts, latency, and so on and so forth. And a lot of effort of those operational teams, platform engineering, DevOps teams, the R&D teams, are wasted in continuous tuning of those knobs of Kubernetes to make to react on the alerts to fix the problems.
Makes sense. Yeah, and exactly what you said about waste of productivity. I mean, that's arguably the biggest thing that engineers are trying to do right now, right? Is optimize not only their environments but themselves, and that's hopefully where platform engineering will come into play. The whole idea of separation of concerns and release cognitive load and all these really cool words that sound great, but let's actually see if they get implemented, right? So that's the obvious goal of platform engineering. So awesome. Now, a couple weeks ago, and by the way, for everybody that's here, please feel free to comment, ask questions, ask us to show stuff, all that jazz. Please feel free. We can see all the comments that pop in here. A couple weeks ago, I did a live stream on just getting PerfectScale up and running, right? So I had one cluster, got the installation going, showed some, menu options, showed, hey, here's what happens if I have standard pods running, et cetera. But of course, I was just getting it up and running for the first time. So the environment was small. So what I wanted to do is I wanted to ask Elli to come on and say, hey, can we actually see a full environment with, a bunch of workloads running, a bunch of environments running, et cetera. And happily and luckily, he said yes. So here we are. And that's exactly what we're going to be doing in this, for the rest of this live stream is we're going to go over what I'll call it a full environment looks like, with a bunch of pods running, a bunch of resources running, etc. Because again, the one that I put out a couple weeks ago, and you can find the recording on YouTube, was just the initial setup and the initial installation and getting everything prepared. So Ellie, if it's okay with you, what I'd like to do is I'd like to pass it over to you, and we can go over the demo, and we'll do a little player coach thing here. So I'll ask a ton of questions.
Sure, absolutely.
Awesome.
All right. So let's start by analyzing a cluster. We have here a cluster running 130 different workloads, deployments, stateful set, jobs, whatever things we're running in the cluster. We currently looking and analyzing this cluster over a period of 1 month. What we can learn from the big picture of this cluster. So the 99th percentile of utilization of our cluster was only 17 cores and 43 gig of memory. This is enough resources to run this cluster in 99% of the cases. This is measured every 30 seconds. But as you know, in Kubernetes, you have to define the resources for each and every container that you are running. And those resources, or the allocations, or the requests and the limits, they are usually set by service owners. So service owner expected to have this knowledge on how much resources I actually need to run my application. And in most of the cases, what happens in this situation is, okay, so I don't really know, I'm guesstimating. And when I'm guesstimating, I may think, okay, my application needs, let's say, 8 gig of memory. So most likely I will not put 8 gig, I will put 16, I will put 32. Why is that? Because I don't want to be waking up in the middle of the night in order to fix this problem.
By the way, I like the waste aspect. I feel like I've looked at a lot of different tools in this space, and I think PerfectScale is the first one that categorizes it as waste. It's a fun word that really pops out at you, and you're like, wait, what? So that's awesome.
Yeah, so the total combined allocation that came for this cluster is 63 cores, nearly 4 times more than we would need. Same goes for the memory, right? We see here pretty much 3 times. But this is not the end, because cluster autoscaler also takes additional assumption, and cluster autoscaler based the assumptions on the request, not on the actual utilization. And this is very, very important part to understand. When you using tools like horizontal pod autoscaler and setting the trigger to be 80%, this is 80% of the request that you set. Same goes for the cluster autoscaler. When cluster autoscaler scale down the nodes, it's at 50%. This is 50% of allocation. This has nothing to do with the actual utilization. So eventually we have additional buffer here and additional buffer here. So we ending up paying for 72 cores to 160 gig of memory, while we need only 17 and 43. So our cluster is extremely over-provisioned. We have like 6 or 7 times more resources than we would need. The expectation in this situation is that, okay, so we're spending a little bit more of money, but at least we would expect the resilience to be fine, right? We have more than enough resources everywhere in the cluster. However, we detected all the waste, but we also detected 74 places where particular workloads are struggling to get enough resources, despite the fact that the entire cluster is heavily over-provisioned. So let's start looking into the workloads themselves.
Right, so let me ask you this actually really quick before we move on. When we're thinking about requests, limits, quotas, a lot of the time you'll see requests set, right? Because it's usually the safest option, so to speak, right? Because you're not limited, but at least you're going to get at least that amount of resources from a CPU and memory perspective for your particular workloads. But to your point, there's also a lot of waste there as well, because you can request, X amount of resources and only use 30 to 40% of them, and the rest are kind of just sitting there. So, in your opinion, do you think that even utilizing things like requests aren't the best way to go?
Yeah, so to answer this question, I will pause for a second the demo, and I would like to present one slide just to explain what we are talking here about.
Sure.
Okay, so this is actually coming from my personal experience. When I have built a few of my first Kubernetes clusters, I have implemented the cluster autoscaler, I have implemented the HPA, and what I expected very good uptime. I expected also my cost to fluctuate together with the load. When I have during the working day high load, then I pay more, but everything is scaling down at the evening and at the weekends. However, when I evaluated what happened in the reality, this is something that I saw. My uptime was not as I expected. Moreover, my cost is constantly grew up. So I tried to understand why this has happened, and eventually, the four knobs that Kubernetes gives you to address the four main knobs, this is where everything starts. This is the requests and limits. The requests, this is what you guarantee to have for your workload. The limits, you may think of them in the best way as the safety valves, because we're sharing multiple containers on the same machine. We want to avoid the situations of busy neighbor when one particular pod, for some reason, started to consume all the memory of the machine and kill the entire machine, and the blast radius then is huge because we lost all the pods of this machine. Mm. And to understand it even better, we need to evaluate what actually happens if we set those knobs incorrectly. So when we look at the request, if we over provision the request, then the result is we're gonna waste money. We're gonna reserve 32 gig, out of which we will not use nearly anything. If we under provision them and set them too low, then the results will be the reliability and resiliency issue, latency, evictions, out of memory, etc. If we do not set them, then we break the entire concept of Kubernetes orchestration, because Kubernetes places the pods on the nodes based on the requests. And if you don't set the request, you actually saying Kubernetes, I am not going to consume any resources. And then you are arriving to the node, and then you're trying to consume resources, but there is no resources for you. So you are evicted, or some other pod is evicted. So this will break the entire concept of orchestration in Kubernetes. And looking into the limits, so when we over provision them, we basically not setting the cutoff switch. If my pod can consume the entire memory of the node, then there is no cutoff switch. It can kill the node. If we under provision them, then again we have throttling, we have evictions, we have out of memories. And if we do not set them, for memory, it's again cutoff switch. For the CPU, it's a little bit different story. This is where we actually recommend not to set the CPU limit at all, unless you know why you are doing this and what is the exact case why you need it.
Cool. So we got a question that came in here, and I think funny enough, we will be answering this question with the demo. But I don't know if you have any other comments in terms of, this question overall, or if, again, if it's just going to be answered more or less in the demo.
Yeah. So the question is horizontal pod and cluster autoscaler, how to fine tune them to optimal performance, or is it anything else?
Yep, that's it. Yep.
Yeah. So we will talk about this during the demo.
Perfect.
And after the demo.
Perfect.
Okay, so let me share the screen back
Sure.
and let's continue with the demo. All right. So, as we said, this cluster is extremely over-provisioned on one hand, but have resiliency issues on the other hand. And this is very, very typical story. We see it across all the clusters that are first onboarding to PerfectScale, nearly without any exceptions. Okay, so let's start with the resiliency. Let's start looking how we can detect the problems, and then we will address the waste. So all the problems are here can be categorized by the severity level or by particular indicators. Those indicators are dynamic, means that at the moment that you see this OOM, it means that at least one workload actively having OOM that you need to address right now. Let's see how does it look like. And for that, let's focus on this moon under workload. So what do we know about this one? So this is a workload which first was deployed on January 9th. So it is running for nearly a month. It has one container, and in this container, we have 1,186 times out of memory. We're running here with single replica, which means that every time we're failing, we are not serving customers at all. Why this out of memory happened? This out of memory happened because someone set the request to be 50, the limit to be 200, and that was the estimation. However, when we look at the utilization, we see that the utilization is very, very close to this 200, and every time we're touching this 200, the killer of Kubernetes simply kills the pod. And how do we fix that? We fix that by here are the recommendations of how much resources you actually need. And as you can see here, we have also CPU throttling. So this is why we need to increase the CPU request and remove the CPU limit. And this will fix the problem with this workload. All those recommendations are here wrapped into the YAML file, so you can just copy paste them into the values file of your Helm chart, run your CI/CD, and you fix the problem. However, in many situations, we are not the developers, we are not the owners of the service. We are a platform team, we are engineering team, we are FinOps team, we're driving optimization. So we can go ahead and open a ticket to the relevant developer. This ticket will contain all needed information about what exactly needs to be done. This ticket will also contain a link leading developer back to the right cluster, to the right namespace, to the right workload, showing the exact same picture as you saw. And from here, the developer can also, we have the integration with observability tools like Prometheus and Datadog. So if this information is not enough and developer would like to see how does it look in terms of behavior of particular pods over time, then we have those predefined dashboards that we are supplying, and you can definitely see how everything behaves. So eventually we found a problem. We know how to fix this problem. We know the impact of this problem. We know also the financial impact of the change, and we can fix and improve our cluster. Any questions so far?
So I would say, what is in terms of the recommended changes, right? Those are, of course, the things that we can copy and paste into our Kubernetes manifest. Now, is there any particular options for automating that process?
Yeah, absolutely, and I will show it in a second. Yes.
Cool. And we did just get a question that popped in here. I will take a look at this tool. Is it free and does it support Mac OS? I think that there may be some slight confusion around what exactly the tool is. So just to clarify here, if you missed the beginning of the live stream, this is a performance optimization tool or resource optimization, cost optimization, whatever you like to call it, in whatever realm for Kubernetes. So this is a tool that's running on one or many Kubernetes clusters, and it's being managed via a GUI or a UI.
Yeah, that's correct. So this is a SaaS solution. You basically deploy an agent into the cluster. This is how you do it. And Michael showed it in the previous stream, but here is the button. You clone the repo, you give your cluster a name, and then you will see the Helm command appearing here to add your cluster. Starting from this moment, all the information about the utilization will start flowing to our platform, and then you connect to our platform and run the optimization sessions.
Yep.
Okay, so let's continue. So we detected the resiliency problem and we learned how to fix them. Let's detect some waste problem and learn how to fix them. So we have here a workload named PSC aggregator. This is deployment running in a namespace of apps, running for 2016 hours. This is the total combined uptime of all the replicas that it is running. Then we understand on top of which instances you are running, what type of instances, what type of reservations, is it a spot instance or a demand instance? And eventually we coming to the price, how much you actually spent on this workload. And what we are saying here is out of $65, you wasting $36, which is more than half. Let's see why. And I'm apologizing for a slight latency that I have here with my internet today.
No problem. Happens to the best of us.
Yeah. So here we can see all the revision, all the code changes that happen to this class, to this workload. And as you can see, this workload is being actively developed and changed. And why it is important, because some changes might be small changes, like you move the pixel left or right, not really affecting anything regarding the performance. But in some situations, you may introduce some heavy query or some internal cache, and then you need much more resources. So following not only the time, but the changes in the code is extremely important to understand how your workload behaves. So what do we see here? We see here somewhere between 3 to 4 replicas. There is an HPA. The HPA is triggered by custom metric, for example, the amount of requests or the length of the queue or whatever trigger it is. And while we're running somewhere between 3 to 4 replicas, each replica is provisioned with 5 GB of memory, 2 GB of 2 cores of CPU. However, when we look at all those replicas across the months, what do we learn? We learn that we utilizing somewhere around half a gig of the memory most of the time.
So this is like a forecasting in a sense, right? Or I don't know if PerfectScale calls it that, but it's kind of like a forecasting or a history of what was utilized for that specific workload.
Yeah, so this is the history and this is the forecast. Okay, so historically, the highest spike across all the replicas was 1.7 gig. Most of the time, we're using somewhere below half a gig. So why we are wasting here for around 5 gig multiplied by 4 replicas, it's easily 3-4 machines, full-blown machines that we can save here. And so PerfectScale again comes with recommendations of how much resources you actually need to set those knobs, again, the requests and the limits, in order to run your workload. And you can adjust the recommendations based on the desired SLA level. So for example, if it's a development environment, then you can set low and save much more money and expect SLA around 95%. But if it's a production workload and you need 4 nines, then you can go to the higher one, and and we will recommend much more. But we will take into account the seasonality waves of your load. We will take into account the the overall trend of utilization. We will take into account machines that you are scaled on, etc., etc. Many different code changes, many different parameters that are being taken here into account when we come into the recommendations.
Now, are these looking at deployments, stateful sets, etc., or are they looking directly at pods, like from the history perspective? Because like if it's looking directly at pods, like what if the pod exits or crashes and then a new one comes up, right? Like, does that history get lost, or is the history portion looking at the full deployment or the stateful set or the daemon set versus the direct pods?
Yeah, so what happens here, this is the aggregation of all the objects that came under apps, under namespace apps,
Got it.
PSC aggregator deployment. So all the pods that were here and attached to this one, this is the combined history of them
Makes
together.
sense.
Okay. Said that, it's another important feature if you're running ephemeral workloads like Spark jobs, like Airflow, like Flint, like runners, we have the custom grouping capabilities. So instead of looking here at the enormous amount of random pods, they will be aggregated based on the labels, based on the container names, based on the machines that they're running on, into something meaningful, into something where you can change the parameters of the particular operator that you are using to create those ephemeral workloads.
Got it. Cool. And for just a quick pause for everybody that's listening, watching, please feel free to ask questions. I've seen a ton of comments coming already. Stuff's getting answered. Really appreciate it. Please feel free to ask any question that you'd like around performance and cost optimization or around, PerfectScale in general.
Yeah. And addressing your last comment about the automation, so here is an example of the automation. So obviously, as we know how to recommend changes, we can also implement those changes automatically. How do you set, to enable the automation, you basically set a label on the level, like annotation on the level of workload or namespace, saying something like PerfectScale automation is equal true. And starting from this moment, our automation will address all the needed changes. If we see that particular workload is struggling to get enough resources, we will step in and add more resources. In most of the cases, we will do it in advance, way before it's actually crashed. For the cost reduction, on the other side, we will do it gradually because in multiple iterations, making sure that nothing is harmed as the result of this reduction. Here we can see the example of workload working under the automation, and we will see in a second how the automation increased our amount of CPU and also increased the amount of memory, keeping this workload live without latency. If we wouldn't do that, this workload most likely would crash or create latency or create some alert, and someone will need to wake up in the middle of the night and fix this. So that's on the active optimization side. Since we have this benefit of knowing exactly where are your problems, and you are managing multiple clusters, we have customers with 40, 60, and 100 clusters running in their environments. It is very, very hard to stay on top of all the alerts, on top of all the problems. And we invested a lot here in reducing the alert fatigue. Why this is important? Let's say we had the workload with 1,100 out of memories. Most of alerting systems will alert you 1,100 times. This creates enormous amount of noise. You cannot really operate with that. PerfectScale will alert you one time, but PerfectScale will keep a very convenient dashboard to show you what you actually need to do. Let's say I'm responsible for the monitoring namespace across multiple clusters. Here are the set of my active problems. They happened first some time ago. They are still here and actively happening. We notified you by these channels. There might be Slack channels, there might be Teams channels, but we send you the notifications. However, they are still here. Let's look at this one, for example. So here's a problem. We have 353 times out of memory. We have single replica. Boom. Problem. How to fix that? Or what is the reason? The resources are too low. We set it request equals limit, which is the best practice for production grade workloads, but it's not enough. There might be enough back then when it's set, but since then someone deployed additional microservice with heavy query, which affects us now, and we are not serving the customers as we expected. So here's a very convenient workbench, and I can acknowledge this problem and say, hey, I'm now taking care of this, and it's fine. I'm now responsible for it.
So this actually leads us into a really good question that just came in. And this is a question that is probably popping up for a lot of people in their heads right now, because the whole managed aspect of things, right? So, for example, this question is, do I really need to worry if we use AKS? I assume we pay for the managed cluster with number of node pools. We won't request for number of cores or memory. Great question. So, unfortunately, even though they are called managed Kubernetes services, they are very much more or less not managed other than the control plane. So one of the things that are not managed is resources, right? So memory, CPU, storage, etc. That is all stuff that is on demand, right? So in the cloud, one of the beautiful things about the cloud is that it's on demand and we can use whatever resources we want whenever we want. One of the bad things about the cloud is that the resources are on demand and we can use them whenever we want. So the pro and the con is almost the same thing. And point being is absolutely 100%. I would actually argue that if you're in the cloud, you have to be thinking about cost and resource optimization more, because you have the ability to literally just grab it whenever you want, versus on-prem you don't. There's a little bit more planning that goes into play there because you only have so many servers. And there's only so many, or there's only so much memory and CPU within those servers. But in the cloud, you can grab it whenever you want. So yes, 100%, you will definitely want to think about cost and resource optimization, even when you're using AKS, GKE, EKS, etc. Elli, I don't know if you have anything that you'd like to add there.
Yeah, so only one thing I wanted to add. Managed clusters are managing only the master nodes. They have nothing to do with the workloads that you are running on the clusters. So managed is, okay, you have your 3 master nodes and they are managed for you. All the rest remains completely your headache or pain, or call it as you wish. All right, so with that, let's continue. The next capability is trends. Okay, we want to understand what's going on in our environments. So here, for example, we can look at the, let's switch to the monthly view. And what we will see the cost per cluster per month. And this is pretty much what you're getting from your cloud provider. You're getting a bill, you're paying for this cluster if you put labels accordingly and you know to pull this information. So you paid $1,300 for this cluster. But the big question is what actually happens here. And let's focus on this particular cluster. And now let's break down this cluster by workloads. And then what we will see, the blackish part here is the amount of extra resources that the cluster autoscaler scaled up and we haven't used. But and all the rest is the workloads. So this is my most expensive workload. It is here. And I'm paid for it a lot, $400. But eventually I optimized and now I'm paying only $78 for it. Now let's break it down to the daily view. And what we will see is how our system behaves day over day. As we go deeper into the resolutions, into the time frames, we start seeing interesting things. We start seeing anomalies. For example, our cluster cost here for day was only $38, but then it jumped to $45, which is 30% more. Assume this is thousands, okay? From 30,000, you started to pay 45,000. So your CFO is coming and asking, hey guys, what happened? In most of the cases, you don't have any answer. Your best answer is developers did something. What exactly they did, I don't know. They did something. Here we can clearly see that this workload started here. It was deployed here and it ran for some amount of days, and then it reduced, and then it started again here. So we have the smoking gun. We understand now how the cluster reacted, and reacted to what actually. Not only cost, but we can evaluate the waste. And we can clearly see how much waste it created. We can evaluate the machines that we are using here, and the machine types. Okay, what are the machine types, how they are scaling, what kind of machines we are using, what is the mix. We can evaluate, okay, so we implemented spot instances and we want to understand how effective we are. Yeah, so nearly 50% of our cost is already on the spot instances, which means we are saving here a lot of money, providing the same exact service. We are good. So this is in a nutshell the reporting capabilities.
And there's a lot of details here, and this is actually a perfect time to bring up this statement that came in. Somebody said Gkey features a resource recommendation engine. Yes, 100%. All the major cloud providers do. I think even some of the smaller cloud providers do as well. But the thing is that they're not coming even as close to being detailed as this tool, as plenty of the other tools that are focusing in the resource and optimization and cost optimization space. The cloud provided tools aren't coming even close from a detail perspective.
Yeah, so I would like also to reflect on that. When when tools like there is a main tool, and Google relies on this tool also. This is a very VPA, the vertical pod autoscaler, and there is two things to think about. The first one is you have to understand the impact, because eventually you don't have all the time in the world to do the optimization. You want to address the most critical issues. The most critical, to understand what is the most critical issue, and I will give just one example. Okay, assuming we have a heavy over provisioned workload, 700% more resources, but this is a job running once in a month on a spot instance. Do we need to invest here? No. On the other hand, we may have something slightly over provisioned, 15%, but we're running 200 replicas on the very expensive node with GPU. Then the impact of our action will be enormous. And this is what is unique in what we are providing here. We are providing here the ability to slice and dice and find immediately all those needles in a haystack where you actually need to invest your time, because your time is precious and you want to take the most the most important actions first.
Yeah,
Second
and
thing,
you know, I'm sorry. One of the other things that I'll say too is like those types of tools as well. When they give their recommendations, it's very much like a one and done thing, right? You know, like a tool like that is like a consultant, and that's funny because I'm a consultant too. Where you know the consultant comes in, they say, "Yep, do this, and you'll be good to go," and you say, "All right, cool." And then 3 months later, or 2 months later, or 1 month later, you're like, "Oh, things are different." Right? But that consultant's not around anymore. And it's very similar with those types of tools where you're not getting history, you're not getting forecast. Like you don't know how things are going to change. And for better or for worse, things are always changing, right? So like let's say you're an e-commerce site and or an e-commerce company, what are going to be your two most busy days? Black Friday and Cyber Monday. So year one, it's going to look like you're using X amount of resources. But year three, hopefully, if your business is growing, you're using even more resources. So that recommendation that you got a year ago, 3 years ago, 6 months ago, 3 months ago, a month ago may or may not be relevant. Most likely it won't be. Again, for better or for worse, you're either using more resources or you're using way less. You're never sitting like this ever. And that's why resource and cost optimization exists in the first place.
Yeah, and last thing is the algorithms. Like the VPA, one of the big problems of the VPA is the decay histogram algorithm, which means that something that happened now have more weight than something that happened back then. Which means if you have the standard seasonality waves where you're consuming more resources during the peak hours and you have less and you need less resources during the off-peak hours, then eventually you will find yourself by beginning of Monday where you need to scale up with less resources than you would need. And then your struggle will start because system will not react, system will create latency, you will have too low resources during the peak period. So safety first.
Exactly.
All right. Last one that I will not go too much into the details. This is a beta feature, but will be very, very soon public. Is the option to evaluate machines. So as I said, everything in Kubernetes is related to the resources, and cluster autoscaler, Carpenter, GKE autoscaler, or autopilot, everything relays on the resources. And let's look into this example of a machine. So this machine, we have two machines running somewhere between running with 8 cores and 32 gig of memory, so 16 and 64 combined. And this is the request that they hold. This is the request that prevents from cluster autoscaler or from Carpenter or from any other tool to scale down those machines. But they are not utilized. And we want to know what exactly is sitting here, and let's remove it. Because if we will reduce the resources here, it will actually jump into one of those nodes, and we will save two machines here and 8 machines here, and so on and so forth. So evaluating the cluster autoscaler, evaluating the types of machines that you are using, evaluating your autoscaling strategies, this is something that we are building right now.
Awesome. So when will that be? Oh, do you have an ETA by chance on like when that will be, like Q2, Q3, etc.?
Yeah, it's somewhere by end of Q1. It's
Oh, nice. Awesome.
a very short period of time.
Sweet. Perfect. Sounds good. So I want to just ask everybody once more, if you or statement, whatever you want to call it, if you have any questions, please feel free to let us know. I'm looking at the comments here as we speak. We're popping them up on the screen. Or if you'd prefer not to have them popped up on the screen, just let me know when you write the comment, and we will answer any questions that you may have about PerfectScale, cost and resource optimization, or, like we just did before, give our general opinion about, other implementations that you can kind of go after. So one other thing I want to just pop into the comments here. Do you by chance have a link for a specific link to a trial that everybody can test out?
Absolutely. Instead of sharing the link, I will just show you. You go to the perfectscale.io, and on the top right corner, there is, let me share the screen for a sec.
Cool.
Yeah, here we go. So you simply click here with the get started, and then the only one thing you need to provide is your work email address. We do not accept Gmail or other things. No other commitments are needed, just your work email address, valid address. And we provide 30 days free trial, no commitment. During this 30 days free trial, you're also getting session, the complementary optimization session, where we are going together over your environments and showing you all the findings and helping you to understand what exactly needs to be done here.
Mm-hmm. Perfect. Sounds good. Well, Elli, before we wrap up here, is there anything else that you'd like to mention? Any shout outs that you'd like to do? Anything like that?
Thank you very much for your time. It was a pleasure talking to you. And guys, remember the main problem, many people complaining about complexity of Kubernetes, but eventually the complexity of Kubernetes is why Kubernetes is so compelling and why it's built to solve complex problems. The problems of pets, we call it the pets versus cattle paradigm, and that's the main challenge, right? You have many pods, and you need to understand what exactly going on. You have multiple environments there, and we helping to close this gap. First of all. The second, yes, we are your trusted advisor to how make everything better. You can keep reacting on the monitoring, and but you can also prevent many different issues.
Awesome. Very cool. Well, thank you so much for joining me today. Really appreciate it. And for everybody that tuned in, thank you all so much. Hope that you enjoyed it. And the recording will be available on YouTube. Thanks, everybody.
Thank you. Bye bye.